Hi all, today I'm going to be talking about Chapter 2, Animals, Machines, Cyborgs, and the Taxi. So this chapter starts off talking about artificial ethology. So ethology is just the study of animals, especially how they accomplish their goals in the environments in which they find themselves. Artificial ethology is, the goal is to fabricate creatures that can do what animals do. And it turns out to be not a very easy task. So some of the things that animals do are often very remarkable. So the examples the text gives are of a lobster finding its way to the source of a scent, and that's very difficult because with the currents going on, there isn't a linear relationship between the density of a scent and how close the lobster might be to the source of the scent. So creating a lobster which can actually accomplish, it's remarkable. The text says that lobsters don't starve to death because that is a seemingly very difficult task that will take some advanced cognitive capacity. And the other example the text gives is of a female cricket finding its way towards a male cricket of the same species based on its song, when there are other songs in its environment that are really very similar. So the goal is to create an artificial lobster that could find its way to a scent, or to create an artificial cricket that could determine distinguish between various very similar songs and find the one that it needs to find. So the goal here is to advance our knowledge with robots as scientific instruments. So it amounts to basically an experimental philosophy of mind. We can test hypotheses that are developed from just strictly computer models, just mathematical representations of an environment, test the hypotheses that we find using those sorts of tests, and develop new ones. And it allows us, so if researchers are trying to build a robot and the mathematical model tells us they're doing it with certain cognitive resources and ways of moving through their environment, and then we create a robot that can do that, and if it fails to get to its goal, then that's useful information for us. It tells us that this hypothesis is not likely to be the case. But if we can, from the mathematical model, then create a robot that can actually accomplish its goal with the resources that we determined, or that we think are the ones that it uses to get to its goal, then that hypothesis is at least plausible. We can't be certain that that's the way the lobster is doing it, but that could be a way that the lobster is doing it, right? So there's some advantages in using robots as compared to real animals. When we're thinking about using real animals for these sorts of tests, we don't have an exhaustive list of their cognitive capacities. Whereas when the robot is created, you are building the cognitive capacities into it, so you know what it's using to accomplish its goal, which capacities are like operative in a sense. So then the authors want to make a comparison between what goes on in artificial ethology and how this plays out, or how it might play out in human research. So an example is with a theory of mind in children. Usually the way that it's determined whether children have theory of mind, and here theory of mind just means the ability to recognize that other beings are looking at things from a different perspective and making judgments on the basis of a different set of information. Usually that's determined by whether they have that capacity is determined by what's called false belief attribution. So a common test, and this happens apparently around 3, researchers will present children around this age with a box that will be marked with a word like candy, and they'll say, look, that word says candy. What do you think is in the box? And the child will say, oh, candy is in the box. And then they'll open it, and much to the child's chagrin, they'll just find pencils in the box. So then they'll close the box, and they'll ask the child, well, what do you think is in the box now? And they'll say pencils, because they recognize that what's in the box is what they saw that was in the box. But then the researchers will ask them, what do you think another child who hasn't opened the box, what will they think is in the box? And the child will say, if they're before 3, they'll say pencils, because now they know what's in the box is pencils, so they just think everybody is working on the same information. But past the age of 3, they'll recognize that other people will be working on a different set of information, and if they saw the word candy, they might think that candy is in the box. So above 3, they should be able, or soon after 3, they should be able to attribute false beliefs to other people, and that's supposed to be a necessary condition for a sufficient condition for knowing that they have a theory of mind, a recognition that other beings are operating on different, sometimes limited sets of information. All right, so some difficulties that computers and robots might help us navigate. First, there might be a question, is theory of mind necessary for false belief attribution? So could it be that we could recognize that other beings would have false beliefs without having a robust theory of mind? Second, even if a theory of mind is necessary, is that what's operative when somebody is ascribing false beliefs to somebody else? Or is it some other cognitive resource that people are drawing on? And finally, could it be that theory of mind is present earlier than a child's ability to attribute false beliefs? Could it be that they already have a robust theory of mind, but because of some other sorts of confusions, they're not able to attribute false beliefs to another being? So just as in the case with the lobster and with the cricket, the use of robots here might be very helpful for researchers, because again, we can build into the robots and we know what cognitive capacities we would be building into the robots, so we could answer questions like, is a robust theory of mind necessary for false belief attributions? And if it is necessary, is it the operative is it the operative resource? And might something have a theory of mind without being able to attribute false beliefs? All of these sorts of questions robots might help us answer, in part because since they're three-dimensional objects in our environment, they might be able to use resources in their environment, so they'd be sensitive to limitations and opportunities in their environment that they might exploit to get to their goals in different ways than we might have even imagined that they would be able to. So the next thing that the text gets into is it gets pretty heavy into Descartes' theory of cognition in animals. So the background here is Descartes a dualist. So he thinks they're what's called a substance dualist. So he thinks there are essentially two substances in the world. So there's physical, material substances, and those are just things that have extension. And then there's a mental substance whose essence is thought, and that's not an extended in space. It's just like the inner mental world that we have. According to Descartes, only human beings had access to this inner mental world. Animals were something like just very efficient robots, or efficient automated things. And the text wants to highlight that we have good reason to have moved past Descartes' dualism, because it brings up some especially thorny problems. In particular, how do these two substances interact if the mental world and thought doesn't have extension, if it isn't like, it's almost like it floats free of the physical world. So how do these things interact together? That's a particularly thorny problem that has plagued philosophers. So the book wants to highlight, one, that we have had good reason to move past Descartes' dualism, but two, that our thinking is still dualist in an important way. And finally, that if we go back to Descartes, we actually see that he has a pretty nuanced view of the cognitive capacity of animals. So let's see if we can lay all that out. All right, so first, the objections to dualism. The authors mention that we have no reason to think that human minds, our thoughts, are not just material. And the reason that the authors give for this is it's especially since we can create material computational devices. So specifically computers. We can create now computers which can do many of the tasks that we thought were only capable, that only beings which had access to mind were capable of. And we also have good reason to think that animals are also thinking things. So in many circumstances, animals will react in similar ways that human beings will. And because neuroscience has developed, we can recognize now that they have shared brain structures. And with doing fMRI, comparative fMRI studies, we can see that they're using similar structures of their brain that we use when we're doing certain tasks and for certain reasons. So then this was kind of mind-blowing to me when I started putting all these ideas together. First, we have no reason to think that human minds are not just material things. Second, we have reason to believe that animals have similar and not totally different in kind capacities that human beings do. So this means even if animals are just material, just fancy robots, really high functioning robots in some sort of way, then human beings are as well. So there's no reason in principle to think that we can construct a robot that has the same sorts of capacities that human beings have. We'll see their opinion gets a little bit more nuanced than my sort of mind blown at this revelation thinking. But that's worth noting. And for our discussion, this week, I'm gonna ask you guys what you think about the various conclusions that are drawn in this section of the text. So check out this section of the text. Be careful and read it over again. So these are some of the objections to Descartes' theory, but there are some replies that we might have on his behalf. Let's take a look at those. So Descartes himself believed that animals were cognitive, just that they had a different kind of cognition. They were like, again, like efficient machines who were performing cognitive tasks. They just weren't doing it in the same sort of way that human beings were. Second, we make a similar mistake that we now think that Descartes made. So when Descartes held that human beings really think, really have mental capacities, but animals don't really think, they just appear to think, we think Descartes now was making a mistake. But we make a similar error as Descartes when we hold that animals really think, while robots and computers only appear to think. Both the authors would say are figuring out ways to navigate their environment and solve complex problems to achieve their goals. And that's just what it means for a cognitive, that's just what a cognitive process is. So here's something that we should recognize. All the parts of humans, animals, and robots are just material subject to the laws of science. So if you look inside the human brain, we'll just see the neurons and the cells that compose our brains are carbon and oxygen and hydrogen and whatever other elements are composing our brains are all just material things. So material substances subject to the laws of physics and chemistry, and it's the same sort of material that we find that makes up animals and animal brains. And the same basic building blocks are there for computers. And when I say the same, there's this similarity. It's all just physical stuff subject to the laws of cause and effect that science tells us about, right? So to think there's something in principle different between these types of things is just wrong-headed. Or at least it's not going to be a difference in terms of what the material is. In other words, there's no thinking element that's in human beings or that's in animals that's not going to be found in artificial things as well, right? But the authors do want to recognize that there is a cognitive process that is distinctively human, at least as of right now, and that's the use of language. So if these things are not completely different ways of engaging with the world, but there is something distinctive about the different types of cognition, then what view are we ultimately left with? The view that we're left with, the authors want to call cognitive pluralism. So we and animals and robots exist in a socially distributed cognitive network populated by different types of cognitive systems that are nonetheless cognitive systems. So the authors want to open up the possibility that humans are cognitive beings, animals are cognitive beings, and robots are cognitive beings, can be cognitive beings. And they want to open up the possibility that social robotics is introducing a new type of cognitive agent that's somewhere between, that's partially a computer and partially a thing in the world, somewhere between a computer and a human being. Let's look at a quote on page 70 here. So this is about the use of language. According to Descartes, what fundamentally sets human beings apart from animals and machines is the understanding and use of language. It is this ability that constitutes the absolute criterion for telling the difference between the two types of cognitive systems that his dualism is meant to keep separate. Now, the authors want to bring those together as types of cognitive beings, but recognize that there are some distinctive qualities of human cognition. Then skip over to 71. There is a firm and widely shared conviction that we will one day succeed in bridging the gap between human and artificial intelligence. What is holding us back, it is believed, are the momentary limitations of our understanding, not any real and permanent separation between distinct types of cognition. So the authors have a very nuanced position here. They want to recognize that there are different types of cognition, but they're not big ontological gulfs that we in principle cannot cross. And that to me is actually fairly amazing, to recognize that the things, the materials from that cause our cognitive processes are the same sorts of materials, or at least they're the same in this way, subject to the laws of science, that we would use to construct robot cognition as well. So the authors want to make an analogy. They want to say artificial ethology is to animal cognition. So the study of animals using robots is to figuring out and learning about animal cognition, just as social robotics is to learning about human cognition. So to study animal cognition, we need to use robots because, as the chapter will tell us, what using robots is to study these things is telling us is that the body is the fact that the mind is embodied, the fact that the brain is embodied in animals is really important, and how they use the information that their body is giving them to navigate their environment and achieve their goals. They'll talk about, the author will talk about embodied mind, that this research is showing us that the mind is essentially embodied, and to try to separate them like the mind is just a computational device, it obscures more than it tells us about the reality of the situation. And also in activism, which you can learn about in a video that I posted. So artificial ethology is to studying animal cognition, as social robotics is to studying human cognition. So how do we navigate our social environment? Social robotics will help us study how we navigate our environment, which is essentially social, and that's going to be the way that it's social, the extent to which it's social will be another distinctive feature of humanity. All right, so the authors then get into a criticism of presenting a theory of extended mind and presenting some criticisms of it. And we'll talk about the reasons why they do that in a little bit. First, we'll set up the view. So I posted a video about this. You should definitely check it out. Somebody, one of the videos is from Chalmers, who came up with this view, and the view is this, that there's no real, so if I want to, an example that they give is this. If I want to remember a phone number, if I'm trying to figure out what my friend's phone number is, but I can't remember it, so I rack my brain trying to remember it, that might be one way that I get to the right answer, figuring out what my friend's phone number is. Another way that I can figure out what my friend's phone number is I pick up my phone and I scroll through and look at their number, and then I press call and call them, right? What Chalmers and some other extended mind theorists want to say is that just that process is equally mine. It's equally part of my mind, in that it's all part of one cognitive process. So just because I'm racking my brain or the memory that's in my brain, similarly, I could use the memory that's in my phone. And its physical location doesn't make it any less mine. It's all part, it plays the same functional role in the process. So they're equivalent in the status of being mine and being my mental process. An interesting view. It has, so it extends our mind beyond where we normally think it's located, like in my head. If the process involves things that are outside, involves me using tools that are outside my physical brain, then it should count just the same. Just as if I implanted like a memory chip, if we advance to the place where we could insert like memory cards in people's brains, we would think that that would be their process. So there's that's like be a middle ground between racking my brain and the phone outside of me. If we could insert a memory chip into people's brains, we would think that that was part of their brain, part of their mental process. Similarly, the phone. So some criticisms of this view. On this view, the mind essentially transforms everything it touches. It's like this weird non-physical blob that sort of takes over the physical world and changes everything into essentially being mental. And the authors want to say this view actually is a retreat to a dualism which we had good reasons for rejecting. It's a retreat to the view that there's an essentially physical, material substance, and then there's an essentially mental substance, and that mental substance sort of takes over physical things and makes them mental. So it relies on this dualistic way of thinking, which we have good reasons for rejecting. Second, and this is a big problem when it gets to talking about taking a taxi, what if the way I remembered somebody's phone number was by asking somebody who was in the room with me? Well, on the extended mind view, is their process, are they like part of my mind now? That seems like a really weird way of talking, and is essentially like solipsistic. So it treats the world as if it's just here for me, for my mind to like grasp onto and overtake and make part of my mind. It starts to sound, it would be really weird to say, if somebody else told me the number, oh, I'm glad my mind got to that answer. That strains the way we normally talk at the very least. And finally, the final criticism of the extended mind theory is the authors will say it's anthropocentric, so human-centered, like in a really bad way. So let's see how they develop that claim. So let me, before I get into why the anthropocentric model of cognition might be wrong, let me first talk a little bit more about what the anthropocentric model of knowledge and cognition is. And that is that it takes human beings to be the paradigm of all knowledge and thinking, and qualities which are, as of yet, distinctively human as being necessary conditions for cognition and knowledge. So the fact that we can be consciously aware of what we're thinking about, and that we're intentional beings, that we can think about what we want to do and then do it. The anthropocentric model of cognition and knowledge takes those capacities that human beings have to be essential for thinking and for knowledge at all. And if something lacks those, then it's deficient in these areas in some important way. So the first thing the text offers us here are reasons to doubt this model of knowledge. So one reason to doubt it is science has extended its reach beyond human abilities. So the text highlights that in the last 40 years, there have been very few advances in fields like genetics, among others. The others being physics, molecular biology, neuroscience, meteorology, and climate research. For the last 40 years, almost all of the findings in those fields have been made by computers, and computers doing processes that we can't do, or at least it would take us forever, longer than a lifetime even, to run some of the individual calculations that are being done to make these discoveries. And in many cases, because of the artificial learning and the artificial intelligence that's working in the machines and the advanced modeling that's going on, we can't even say for any instance of a computation whether that computation is right or wrong. We can see that some models work better than other models when trying to determine what's going on in the climate, what we should expect with gene combinations and resulting traits. So some models we can see the results of, that they work better than others, but for any individual computation, we can't tell whether it's right or wrong because it's a little bit like a black box where it's not available to us. So it would be weird on the extended mind theory to say that when a computer is doing these calculations and that we see the end result, that's part of our mind doing that thing, that's my mental process. It's weird to say that because I can't do that. And even the person who builds the machine isn't always capable of doing the calculations that the machine is doing itself. So it'd be weird to say that that the scientists looking at that's part of their mental process, that's their extended mind doing that. When instead it seems easier to say that the computer is thinking about these things and this is the result that it came up with, that it's the computer's cognitive process, not the scientist's cognitive process, or not certainly my cognitive process looking at the results. But there is a response to this, and that's that what's essential to knowledge here is that there is a human being at the end of the process looking at the results, that there's a human at the beginning and a human at the end, a human kicking off the process and a human at the end looking at the results of the process. And it isn't real knowledge until the human, until a cognitive, conscious, intentional being looks at the results of the process that the machine's going through. And this view is supported by a recognition that we're not aware we're not consciously aware of all of the subpersonal processes that sometimes lead to human knowledge. For example, we might not be intimately aware with how our eyeballs reconstruct images in the world, but that can inform, we certainly would call that part of our mental process, part of our learning process. So in a similar way, maybe we should say that the machines are just like sub-personal processes, like our eye processing an image, that lead towards knowledge, and they only count as knowledge and thinking and cognition when we're at the end of it. But there's a rejoinder to this response. If the determining fact of whether a process counts as knowledge is that it comes to the awareness of a being with intentions who's consciously aware of what's going on, then some processes would not count as cognitive until they'd be only contingently cognitive until we became aware of them. And that's really weird. The text gives a nice job with a nice example with a missile defense system. And this is on page 84 and 85. So the Patriot air and missile defense system developed by the U.S. is entirely automated. It contains a subsystem of radars that are linked to a computer. When the approach of an enemy missile is detected, the computer calculates the trajectory of the incoming missile and an interception trajectory. A Patriot missile is then launched to destroy the incoming missile. All this takes place automatically without any human intervention. For the moment, at least, the system is supervised by human operators who can cancel the launch of a Patriot missile in the event that the automatic system has made an error. For example, if it has confused a civilian airliner with an enemy missile, that would be a big error. The operator's room for maneuver is extremely limited, however, a few seconds at most. Beyond that, it will be impossible to intercept the incoming missile. Response time is crucial. It is the reason why the system was entirely automated in the first place. Human beings are too slow. They're incapable of recognizing an incoming missile and calculating an interception trajectory quickly enough. Do we really want to say that that missile system is not a cognitive system? It recognizes an incoming missile, calculates its trajectory, calculates an interception trajectory, and launches a Patriot missile in response. Surely it would be really weird to say that this system is cognitive only when a human being supervises its operation. The very fact that we depend upon a human being to supervise the system suggests that we are indeed dealing with a cognitive system. The human operator is there to guard against the chance that the system makes a mistake. Mind you, only cognitive systems make mistakes. Mechanical systems break down, but they do not make a mistake. But here it seems just really natural to talk in terms of the machine correctly identifying a missile and taking an appropriate response, or making a mistake in determining what counts as a missile and making a wrong response. So, the view that the authors have been building to, they want to draw some conclusions with regard to in the area of philosophy of mind. So they want to say that minds are essentially embodied, inactive, and not extended in the sort of way that the extended mind theory would have us extend them to privilege our own mental processes, and such that all the mechanical, what seems very natural to say, all the automatic cognitive systems that are going on around us are merely parts of our own mind, where it seems much more natural to say that there are different types of cognitive systems. Some rely on conscious recognition, some rely on being part of intentional systems, and others, like the Patriot missile system, do not. Humans, animals, and robots are all part of a socially distributed cognitive network, And though there are some distinctive features of each kind of cognition, there's no big ontological gaps between. There's nothing that will forever make it impossible that a robot can't do the sorts of things that an animal can do or the sorts of things that a human being can do. Whew, that was a lot. All right. So now we'll wrap up with just a couple of quiz questions. So first question, true or false? The authors of our textbook are dualists. Is that statement true or false? You'll answer that on the Canvas quiz on this lecture. Question number 2. According to the authors, why should we not believe in an anthropocentric, a human-centered model of cognition? A, the human mind transforms everything it touches. B, we're not aware of some subpersonal processes that contribute to knowledge. Or C, science has extended its reach beyond human abilities. All right, so answer those 2 quiz questions in the Canvas quiz for this week. And check out the discussion question. By the time you see this, it will already be posted. I look forward to hearing what you have to say on the discussion topic, and make sure you respond to one of your colleagues to get full credit for this discussion. All right, thanks again. I'll see you next time.